Now moving on to the second problem. The Food Safety Authority is inspecting a meat processing plant amid the horse meat controversy. The inspector selects 12 burgers from a batch of 100. Okay, the batch actually is of 100. We are selecting only 12, and if we are testing if it contains horse meat. Unknown to the inspector, 32 of the burgers in the batch contain horse meat. So let's compare that with the parameters of the hypergeometric series. So n is the number of items in the population, that is the whole batch. So that we would take at it as equal to n is equal to 100. That is the total batch size which we are doing, and the small n is equal to, that is the sample size which we are selecting is 12, and the r, that is the horse meat in our case, the number of items in the population that we classified as success, that is the horse meat in our case, is equal to 32, because there are 32 burgers, 32 of the burgers in the batch that contain horse meat. The first question is, what is how many of the burgers selected by the inspector would we expect to contain horse meat? So for that, the answer expected, we need to calculate the expected value. So that is nothing but mu is equal to the expected value of x. E of x is equal to, as is given in the formula, you can see it here, that is nRn. N times r upon n is equal to, the n is 12 times 32, this upon 100. You can see the answer to this would come at 3.8. Now the question is, what is the probability that at least 2 of the burgers in the selection contain horse meat? That is, probability that at least 2 of the burgers, that would mean that x is greater than or equal to 2. Okay, we need to find out what is the value of this probability that x is greater than or equal to 2. So but if you do this, like n is 12, so x can be 2, 3, 4, 5, 6, it can go on up to a large number of 12, I guess. So we can use a trick over here. We know the total probability is equal to 1. Okay, so 1, I'll just rewrite the statement. We want only this term, so probability of x is greater than or equal to 2 plus probability x is less than 2 would be equal to 1. Okay, you can use this trick anytime, like x is equal to 2, x is equal to 3, x is greater than equal to something, x is less than something. The whole total probability would be equal to 1. This can be 2, 3, 4, anything. This can be anything. But both of them should be equal. Whatever is here on the greater than equal to sign must be there. Okay. So now this is the term which we want. You can write this as equal to probability of x is greater than or equal to 2 is equal to 1 minus probability x is less than 2. Okay, and what is probability x is less than 2? If x is less than 2, x is the number of items in the sample that are classified as success. So x can take only two values, like x can be either, if x is less than 2, x is a number, integer, so x can be either 0 or 1, it cannot be 2. So we can write this as equal to probability x is equal to 0. This is the whole negative sign over here. So this is negative, probability x is equal to 1. Okay, and seeing the formula over here, which is written as this is probability x is equal to something, Rx. So let's rewrite this formula over here. Probability, you can just compare those formulae. X is equal to 0 would come as, see, this is Rx. R you calculated as equal to 32. X, so you just rewrite this. Let me write that. Okay, see, R is 32 and X is, we have taken it as equal to 0. N is, comparing in this formula, N is 100, capital N is 100, small n is 12, and this is N minus R and N minus X. N minus R is 68, 100 minus 32 is 68, and this is N minus X, small n minus X, that is 12 minus 0, that would be 12 itself. So calculating this, you would get the answer of this calculation. I am getting it as equal to 0.007. Similarly, you can calculate for probability of x is equal to 1. X is equal to 1. So the x terms, the terms containing x would change. This will become 32. This is Rx, so 32 1, and this will remain. N minus R is 68, and this is 12 minus 1, that will become 11, and upon this will remain same, that is 100 C12. 100 C12. Okay, calculating this, you would get the answer as equal to 0.047 is what you would get the answer as equal to. Now just substitute those values here. If this is equal to 1 minus probability x is 0 is 0.007 minus probability x is equal to 1 is 0.047. So calculating this, you would get the answer. So the final answer, that the probability that at least 2 of the burgers in this selection contain horse meat is equal to 0.946. As expected, like it is 0.946 is the real number because 3.84 is the expected number. So obviously there would be more than at least 2 of the burgers would contain horse meat. So that's why we are getting 0.946 or 94.6% as the probability. In the third problem, what we would be doing is, the daily sales income as generated by a Grafton Street follows a normal distribution. That is, the S is following a normal distribution with, like the notation is, mu is the mean and sigma square is the variance, the square of the standard deviation. So you can write this as the S is following a normal distribution with a mean of 2000 and standard deviation of, sometimes only sigma is written, so you can write just sigma square. Here this is a sigma. So mu is 2000, the mean is 2000, and the standard deviation is given as 200 in this normal distribution. The other is the uniform distribution given to you. The daily overhead cost, the C, is denoted by a uniform distribution. The limits are A to B, 200 to 400. So you can, this is the notation. Like actually the notation, if you go by, it is A to B. That is from what point to what point the uniform distribution is defined in this case. And C The limits are here, they are given as 200 to 400. Okay, yeah. So in this case, let's calculate that later. Let's go to the first problem. 3a. The third A part asks you calculate the probability that the sales income, sales is normal distribution, this one, is between 1800 and 2100. Okay, probability that X is between 18 to 2100. Yeah, so this, now the first thing which you need to calculate is the z value. Z is given by x minus mu upon sigma. You must be knowing this. So for each of these x values, for this and for this, you calculate the z values. So the z1 for x is equal to 1800 would be, this is x is 1800 minus mu is given by 2000 upon the sigma, the standard deviation is given by 200. So on calculating this you would get it as equal to -1. Similarly, on calculating the z2, that is the x minus mu upon sigma, x2, like here you can say that the other one is x2 is 2100, the on the right hand side of x, minus the mu is 2000 upon 200. So that would give you 100 upon 2100 minus 2000 is 100 upon 200 is 0.5. So you can standardize this, like we are doing the standardization. So probability of the corresponding z scores we will be inserting here. So here 8100 was nothing but -1, and the corresponding x would become z, and 2100 would become 0.5. We just substituted those values, and whenever this is of this form, ranging from like probability z is ranging from a to b, I'll write more clearly. This is a to b, then this formula is probability z is less than b minus probability z is less than a. So following that, we could write that this is equal to probability that z is less than 0.5 minus probability that z is less than -1. So you need to see a z chart for this. I'm having a z chart which shows the 0.5, z is equal to 0.5, the value is given by 0.69146. So I'll just copy that. This probability z is less than 0.5 is 0.69146, and this probability z is less than -1. So you search for -1 over here. you will get it as equal to 0.15586. Okay, okay. Now you just need to calculate what's remaining in there, and you will get the final answer. You will get the final answer as 0.5328. That is the probability that the sales and income is between 1800 and 2100 is 0.5328. Now coming to the part B of this problem. Calculate a 90% lower bound for S. Okay, I'll explain it graphically. So 90% lower bound, right? And this is the normal curve, and here suppose lies the mean. 2000 is the mean. So you can say so 90% lower bound. That would mean that 90% of the area is above this. 90% of the area is above this. So hence this would become a lower bound. So for that we need to search the Z table. Like it would mean that probability that Z is less than something, like on a Z score this would be 0, on a standard score is equal to, what would be this area? This would be equal to 0.1. Then this is 90%, this would be 10%. So this is 10%, so this would be equal to 0.1. So searching that, like this is the inverse normal distribution which we are doing. So you would search for Z is equal to 0.1 here. So 0.1 we would get it somewhere here. This is 0.08, 0.09, okay, somewhere around here, 0.09853, 0.10027. So I could say that it is equal to, it's negative 1.28. It is approximately equal to, this is 0.1, 10%. Okay, so this is negative 1.2 and negative 1.28. So I'm approximately taking the closer value, which is here. Yeah. So negative 1.28 would be our value. I'll write it here. Negative 1.28 is the value. Like 90% of the 10% of the values will lie below this, and 90% of the values will lie above this. So that's what is meant by this. So if Z is equal to negative 1.28, that is the Z critical, the value above which 90% of the values lie. So Z is equal to x minus mu upon sigma. From this you can find the value of x. X would be equal to mu plus Z times sigma. So that would give you, mu is 2000 and Z is negative 1.28, that because you will get a lower bound, and sigma, the standard deviation, was 200. So calculating that, you would get the final answer as 1744. So this is the lower bound, 90% lower bound for S, the daily sales income.